All right. Hey, hello everyone. Done another stream here. Let's see if it. Hey, hello. Okay, good. All right, just checking the audio on the on my own live feed. So today is more work on the EVPN VXLAN cookbook. So haven't worked on this in a hot minute, but wanted to get some stuff done, and live streaming really helps me like be concentrated and also explain things out. And I can't do the whole thing through a live stream, but it helps me to do some of it through a live stream, and you get to watch and hear me drink tea. And okay, so let's try. So where did I leave off? I don't remember. One thing I might have left off. Oh yeah, I was trying to do multicast in the underlay, and I was able to get it to work in a virtual environment, but I wasn't able to get it work in a containerized environment. So in EVPN VXLAN, we have to have a way to deal with flood frames. So a frame comes in, it needs to get flooded to all the other hosts, all the other ports on that layer 2 domain, the bridge domain. Think of it as a stretched VLAN. And we need a mechanism to do that. So by default, Arista does head-end replication. So the switch itself will make a copy, encapsulate each copy, send it to each other leaf in the network. And the leaf knows what other leafs have that bridge domain because of the type 3 route. So when you configure a bridge domain on a switch, it automatically generates a type 3 route saying, hey, I'm at route inclusive multicast Ethernet tag. Send me a copy of every flood frame you have for this VLAN. It's not really a VLAN, but we'll just call it a VLAN. And Tristan says, "Man, I got a lot to watch from you. I've been back in the campus access game." Yeah. Are you doing campus access in the with VXLAN, EVPN VXLAN? It's one of the probably the biggest growing use case for EVPN VXLAN. It's been mostly data center for a while. We're seeing it more and more on the campus. So you can do it by head-end replication. You can also do it by multicast. So every VLAN joins a multicast group. So when you get a flood frame, you just send it to that multicast group, and then your multicast infrastructure handles doing the replication, sending it off to the off to the leaves. You generally won't it won't result in head of line blocking. So your frames won't have to. Your other packets won't have to wait behind like 100 copies of the same frame as they're serialized out of your leaf, your ingress leaf. It's not as common. It's got some advantages, but it's not generally a huge benefit. So most people do head-end replication because it's a little bit simpler. It's a lot simpler because you don't have to do multicast, and people are terrified of multicast. And I think people are terrified of multicast mostly because if you don't do multicast on a daily basis, its use case is pretty limited. And if you're in an environment where you're not doing multicast every day, every week, every month, then it's a skill set you can lose really quickly, like any other skill set. So, and it's certainly the case for me. And I think for most people too. So let's see what we got. What did I leave on these things? Okay, so yeah, multicast group. So this is multicast in the overlay, but it's not multicast in the underlay, and that's okay. There was AVD was not generating configurations that did multicast. There is a pull request in flight. Someone told me about, where they're going to add multicast. I think it was from something I asked about. Multicast. Yeah. So this one. So apparently they've got a configuration in there that will build a multicast underlay. Is this it? Flooded traffic using multicast underlay. Yeah. So the next release probably will have it. They don't right now, but that's okay. Because I made a... because I think I made... Man, I already forget what I did like a week ago. Oh, I didn't create... No, I did this manually. All right, we'll do that. Okay, so I think right now it's got a configuration from AVD on it. That's because this is an AVD config. Because my templates don't generate route maps. You don't have to do route maps. Just one of the ways that you could do it. And head and replication. Deploy. All right, so we'll go ahead and do... I'm just going to have it build out this, deploy this. So which one should we do? We'll do, let's do OSPF unnumbered. No, we'll do BGP. We'll just do this one. This one's kind of a very generic one. Head and replication, eBGP, all active. So that'll push that to the devices. So that'll give us head and replication. And then we can switch it over to multicast to see if it works. This is the containerized. Oh, yeah, that's what I was going to do. There's a new version of containerized EOS out there, so I'm wondering if they've added multicast support in. So I just wanted to try that real quick. And let me try bringing myself back, because I was working on this like 2 weeks ago and I haven't worked on it since. I got a bunch of stuff I want to do. I like that it gives me the color. What am I doing? Which release is this? 9.6. Okay. 220. Now, where's my C-Lab? There it is. That's the one I want. And just dump it in here. I'll do sudo docker import EOS lab 434.1f EFT3. I think EFT is if extended functionality. I think that's what it means. I don't remember. COS 434.1f EFT3. So that'll import that into the Docker image library, and then I can run that. So it's running that. All right, so it's done. And then so basically I want to change this. So sudo docker image list. And this is the version I want to run. So I replace this. I could do change all occurrences. There we go. So I've got to destroy this. That's okay. So container sudo container lab destroy. It just takes it all down, and then I can do deploy. So that'll give me the new version. Well, that's being done. Sudo docker exec -it host1 bash. No such container. It's not done deploying yet. Did I make a notes? I don't think I made any notes. I should really have made notes. On the commands that I would need to run on the, yeah, I didn't make any notes. Because I need to set up, a bunch of stuff on the Linux containers. I really need to figure out how to make my own custom containers, but I did not do that. So there's always a ton to learn in automation, in the tools and the ancillary tools, like how to make my own Docker container image, and that way I could load up like a utility image, which would be pretty neat to have. All right, so now I'm on a container. I can do, so I'm root on this container, and I need to do IP or DNF-y install IP route. And then DNF-y install EPEL release, which is a extra repository that has some other utilities in there. And so that way I can install, what was it, iPerf. So I'm already moving over to Alma Linux 10. Okay, so I've got iPerf. I think that's all I needed. And I've got two interfaces. Oh yeah, I wanted to install LLDP. DPD. Which required a ton of Perl for some reason. And then that way the devices can actually detect it. So I can go into admin at leaf 1. I can do show LDP neighbors and I'll see host 1. And that's its MAC address. So that's running LLDP, which is nice. I really like LLDP. And it's nice to have the servers running it too. Do I have a bash history? I don't have a freaking bash history. I was going to use it to make my notes. So DNF-Y install Apple release. DNF-Y install IP route. DNF-Y install iPerf. DNF-Y install LLDPD. LLDPD. I think that's all I needed. Go to host 2 and do the same thing. Ideally, I'll make a custom image that already has all this stuff installed. So if I go to leaf 3, I see host 2 or host 1, host 2. No, I don't. Yeah, I do. Okay, good. That's good. Huh, that's weird. The config's still there. Show version. I did just restart everything. No, it didn't. How is it up 19 days? That's interesting. Sudo container lab destroy. Okay, and deploy. Oh, the uptime might have been the actual host. Yeah, it's a container, so it wouldn't have known the startup time. It looks like the configs are persistent. I thought they weren't persistent, but I guess I'm wrong there. Okay. Oh, there's a command to change the MAC address. I was going to change the MAC address. Change MAC address Linux. Run these commands again. When I'm doing labbing, I like to change the MAC address of the host to like 1, just all zeros and then 1, all zeros and then 2. So it just makes things a little bit easier. Installing all that stuff. And yeah, it's just the host. So if we do show LDB neighbors. Oops, leave 1. Okay, good. So I'm going to change that 9 Bravo Charlie Delta. See which one. So Ethernet 0 is management 0, 9 Bravo. Okay, Ethernet 1. So I need to do IP link set dev Ethernet 1 address 0200. So I did the 02 as the first octet because 02 in the first octet in for a MAC address means that it's locally administered. So it means you nothing burnt in will ever have that MAC address. So that's a locally it's like an RFC 1918 address space for MAC addresses. And so that's that. And then if I do show LDP neighbor, there it is right there. That's exactly what I was expecting. Let's try host 2. Run those. Careful, I can replace you with a bash script. Okay, and then plink set dev Ethernet 1 address 02. There we go. And so if I got to leave 3, there it is. They each have a second interface. I'm not doing anything with it. So there's actually 4 interfaces on each Linux host. And they can go up to leaf 1 and 2 and leaf 3 and 4. But we're not going to do any lags or anything like that. We're just going to do a single IP address. And I also need to set the IP address. So set IP address, add 10.1.10.12 device Ethernet 1. Oh, sorry. IP address, add 10.1.10.11 dev Ethernet 1. Okay. might be able to ping the other. No, it's not set up. The other thing I can do is IP route. So it's going at Ethernet 0. So I'll just set IP route delete default. And then IP route add default device Ethernet 1. I don't even need to set an IP address. It just sends all the traffic out through that interface, which is interesting because we don't really consider that in networking. In a network device, we don't say just send all your default route traffic at this interface without specifying a next hop. In Linux, we can just say send it out this interface. Probably can do that in a router switch, but I don't think I've ever done it, so I don't know if I can. So this would be IP route delete default, IP route add default dev Ethernet 1. All right, so now they're all set up that way. 10.1, 10, 11. Should run interface Ethernet 10. What do I have configured here? So I think I just have to VLAN 10 there. Yeah, that learned both MAC addresses. Should be able to ping now. Yep, there we are. So this is why I manually set the MAC addresses, because it is lovely like that. That way I know exactly which one it is instead of seeing some random alphabet soup. So it's not necessary, but it's a nice little thing to do. You can also manually set the MAC address on a router interface in EOS. So I could do router MAC address or MAC address router, and then specify MAC address, but I'm not going to do that. I don't need to. So I can ping. Now I can see. Why does it keep doing that? I can do iPerf. Host 2, host 1. So iPerf multicast. Let's see if it works now. No, it actually should work. I know this should work. So it's my multicast server. And then my multicast client. So server on host 1, client on host 2. Okay, so that does work, and I was expecting it to work because we're using headed replication. So I'm going to configure this. So I'm going to configure this for the other way now. So I did eBGP. I'm going to create a copy here, and I'm going to rename this MCAST. Rename each one of these MCAST. At some point, I will make a Make a template to do this. Now, multicast in the underlay, I don't see a lot. I think most people, if they can get out of doing multicast, they'll get out of doing multicast. And I really don't blame them. But sometimes it's a good idea to do. So the multicast config is going to be see what we got. Okay. Oh, kernel. Interesting. Oh yeah. So yeah, we're not using multicast. Okay. Router multicast, IPv4, SATA forwarding SFE. Was that in the config here? I don't think I actually had it in the config. No, I didn't. I don't know why it defaulted that. Okay, so, and then we do, yeah, so we do router PIM sparse mode. Set a rendezvous point. I don't know if I need to set a rendezvous point here, but we do need set a router there. And so then Ethernet 3 and 4, IPv4, IPPIM, IPv4, sparse mode. Trying to remember how to set that. Yeah, I think that's it. So then we go to the spines. Router PIM sparse mode, IPv4. I think that's all I need. Oh yeah, I need to say that on the rendezvous point. Copy that. And then I need show IP interface brief. So I have that configured. I don't. So I need to interface loopback 10. IP address 192.168.109.10. I see that in the leaf. Show IP route. Yeah. Oh, wait, did I? Oh, I don't. Yeah, no. Interface loopback 10. Oh, I configured this on the frickin', thought it was on the spine. All right. Interface loopback 10. IP address 192.168.109.10. It's not being advertised, so I got to put it into BGP. address family IPv4, show run section BGP. Yeah, so network statement. So that should announce it to the other leaves. Yep, there it is. All right, so we got that there. And then interface E3, 4, 5, and 6. PIM IPv4 sparse mode. Show PIM neighbors, or IP PIM neighbors. Oh, I need to set up multicast routing. Should see neighbor statement there. Oh, multicast routing is not. That's another command I'm missing. I thought I had it. Where's the PIM not pimming? IPv4. That's another command I'm missing. No. Why in the heck? Oh, routing. I'm missing the routing command. Jeez. Router multicast. IPv4 routing. All right. Show IP PIM neighbor. There we go. So neighbor. And I need to do this on spine 2. What was it? Keep hitting that button. PIM IPv4 sparse mode. All right, so that works with leaf 1, and then we'll need to do the same thing for leaf 3. All right, so now I've got neighbors. Looks like I'm getting MRADs. Okay, so now I want to configure the leafs. Interface VXLAN 1, VXLAN VLAN 10, and flood group 239.00.10. So if I do show IP PIM, what do I want to do? RP. Show IPM route. I do see a join. Okay. If I do show show BGP EVPN route type, IMET detail, should see PIM SSM tree. Okay, that looks good. Leaf 3. And then 10, flood 239.00.10. Flood group. Show IPM routes. So it should do a join. Looks like we've got a join going on. And previous versions didn't work, so I'm just going to try this. It was a lot of work to get all this done. Doesn't appear to work. Yeah, I could try the 224 range because that's always going to get flooded instead of, or should always be flooded, I believe. 224.0.100. Now it's always going to show that it works in the sender because multicast is UDP, so there's no acknowledgement. We just spray packets out. Did the receiver get it? So it doesn't work there. But that's what I was expecting. I was hoping it would work, but I wanted to try the most recent version. So we can get back to the other stuff. I'm going to hit the restroom. Be right back. And we can continue on. And make myself some more tea. I'll be right back. just realized I made a typo in the video title, so I'm gonna fix that real quick. Arista. It's Arista. Not exactly my favorite company right now. All right, so my mouse is all laggy. I've been getting that lately. I don't know why. It's one of the problems with these modern systems. Is a problem crops up and you have no idea where the problem could be. On networking, it's actually a little bit easier because there's not that many places a problem can hide, at least when compared to a complex thing like an operating system. All right, so we've got configurations and so forth. So where did I leave off? Let me open up a new PowerPoint. I don't think I have Dropbox started up. Come on. This mouse thing is... Just want the mouse to work. Dropbox. So fundamentals of EVPN VXLAN is we do a topology, we do an underlay, we do an overlay, and we do EVPN services. So the cookbook's going to cover each of these, and probably the most choices we have is in the underlay, but we do have to make some choices, and we're going to put that in the book. So choices for EVPN VXLAN. So we have the multi-homing strategy. So we can either do MLAG or we can do EVPN all active, ESIs. So that's a multi-homing strategy. Next we do flood. How do we handle flood frames? And then we can do head-end replication or multicast. Then we do the underlay, and we can do, we have either IBGP, EBGP, ISIS, or OSPF. And we can do numbered or unnumbered. And what other choices do we have to make? For the overlay, it's either IBGP or EBGP. And then for EVPN services, we've got a couple choices. We can do symmetric or asymmetric IRB. We do VLAN aware bundles or one VNI per VLAN or one MAC VRF per VNI. And then we have our logical policy choices. Logical policy choices. So that would be like how many VRFs, or sorry, tenants, VRFs, anycast gateways, etc. So those are all choices we'll have to make. Multi-home strategy. So let's do a chapter on multi-home strategy. I think I might already have one in there. Topology. Yeah, it's right here. One of the considerations for topology, one of the choices you need to make for any given topology is what method of multi-homing to host is going to be used. With Arista EOS and EVPN VXLAN, there are generally two methods for multi-homing a host. Multi-homing is when a host is plugged into two or more leafs, so that if one leaf is down for maintenance or has any kind of failure, or a link fails, the connection survives on the remaining leafs. In either case, a host sees a lag connection, typically with LACP. I sees a lag connection to a single switch, when in reality it's a lag spread across multiple switches. Sees a standard 802.1, 802.3AD, 802.1AX. So there's, in IT in general, there's some times when a newer version of a standard is used, but we still refer to the old one. For example, 802.3AD was the old working group that came up with link aggregation, which is what we use for port channels, ether channels. It also contains LACP. It has been deprecated in favor of 802.1AX, but almost no one knows it is 802.1AX. We all know it by its old name, 802.3AD, and that came out in 2000. So it's been around for 25 years. Another one is that RFC 5549, which we use a lot in terminology, has been deprecated by RFC, was it 8950? Yeah, 8950. But almost all the Arista documentation refers to 5549. I didn't even know that 8950 existed until I watched a video on how Facebook got rid of IPv4 addressing and all their point-to-point links. Pretty fascinating video. So one of the choices you need to make for any given topology is the method of multi-homing your hosts. So, and then I need to open up a file here. Because I have a browse. I have a PowerPoint that I'm using to store all the diagrams. So I need to put a diagram in here. I think I have Dropbox. I should have Dropbox running. Oh, no, it's not running. Why the heck not? All right. So new slide, and this one will be multi-homing. So normally when you write a book that's going to be printed into paper, you generally will just do black and white because that's what's going to be printed. But I don't have any plans to actually print this. This is going to be an electronic book only, so it'll be available on Amazon, probably. LeanPub. That's where I plan on publishing this book. I decided not to write a full book because that takes a long ass time. Be a leaf. And I'll do a copy because I need to do multi-homing for EVPN all active, and then multi-homing MLAG. So the biggest difference between the other multi-homing methods, I just gotta get rid of these. Is that MLAG is restricted to 2, which is not really a big deal. Some people make kind of a big deal out of it, and I don't really see the problem. Because most of the time when we had a rack system, we're limited to 2. So the thing about MLAG that apart is that we've got to eat up a port on each device for our peer link. Two ports actually. Typically we'll have them be redundant somehow. So I used to prefer MLAG because it's a little bit more straightforward to troubleshoot compared to EVPN all active. But I've kind of come around on doing EVPN all active, and the reason is the flexibility you get. So the reasons that people tend to say that they want to do EVPN all active is that it's an open standard so that you can build a Frankenfabric with multiple vendors, whereas MLAG, the 2 switches in that MLAG pair have to be the same vendor. Now I could have leaf 1 and 2 be Cisco and leaf 3 and 4 be Arista, and that's fine if they're in their MLAG or VPC pair. But leaf 1 and leaf 2, in this case, because they're in an MLAG domain, they have to be the same vendor. They have to, in fact, they have to be the same hardware and the same code. And there's some limitations Like if you're going to do an upgrade on Leaf 1 and 2, you have to make sure that they're compatible for the upgrade, because Leaf 1 or 2 will be in a slightly different version of EOS during the cutover. And if you want MLAG to keep working, you need to make sure that they match up. So that is MLAG. And I'm just going to get rid of this. Well, save that maybe for later. And then there's EVPN all active. So EVPN all active doesn't have any connection between the two. And you can actually have more than two. You can be connected to more than two devices. MLAG is always going to be just two devices in a pair, and you can't mix and match. It's got to be the same two devices because there's only one MLAG domain. So I did this because I need to create images. And then put them into the directory. Oh yeah, I want to do an MLAG domain. I always do a circle or a dotted boundary here. So I do something like this to denote an MLAG domain. So no fill, it's red, and then the do dotted. And then something to denote MLAG domain. Yeah, there we go. So I should do this by images. So I don't need I don't know why that was in there. That's a good one to have. And then I'll do copy this into there and this into there. This will rename to multi-homing EVPN all active. And rename this to multi-homing MLAG. The more traditional method for multi-homing is known as MLAG, multi-chassis link aggregation. MLAG has been around for over 15 years and is generally trusted on the Arista platform. I've heard rumors that people don't like it on Juniper. Juniper apparently is not super strong on the data center front, which is interesting. So over 15 years. I don't remember when MLAG was first introduced. For a while, predating EVPN all active, and is generally trusted on the at least on the Arista platform. With MLAG, two switches are joined into a pair called an MLAG domain. And those two switches are presented to the outside world as a single switch from an layer 2 perspective, but they are separate layer 3 devices. So that'll come up later. Both switches in a given MLAG domain have the same bridge ID for spanning tree and this same system ID for LACP. So I think this will be a good place to put is multi-homing MLAG. So let's take a look at the preview. Yeah, that looks good. Another requirement for MLAG MLAG has a couple of requirements. Peer link configuration and hardware and software limitations. It requires a peer link, so generally 2 of the host-facing ports are dedicated to this peer link. So generally 2 of the host-facing ports are configured for a port channel lag and dedicated as this peer link. Exchange switch state information as well as provide an alternate path in certain data plane situations, such as uplinks or downlinks, uplink or downlink failures, on one of the leafs. Interesting thing about the terminology leafs. Now, we would normally say leaves in English, so it would look more like this, but in networking, the plural of a leaf is leafs. It takes a little getting used to. But as far as I could tell, all the Juniper, Cisco, Arista, they both follow that convention. So I don't know what style guides these are using here. Oh, we got some software. Another requirement for MLAG is that the hardware needs to be the same vendor and even model on both for both switches, the MLAG domain, as well as restrictions on the EOS code version. If you are upgrading from one version to another, you'll want to consult an upgrade guide to tell you if there are intermediary code versions required for a rolling upgrade. The other option is using aspects of the EVPN standard called Ethernet segment, also known as standard called EVPN All Active. With EVPN All Active, there's no MLAG configuration on the leafs, nor MLAG domain, and there isn't a peer link between leafs. Oh yeah, and hosts can only home to a single MLAG domain per lag. When connecting host to an MLAG pair, a given lag port channel, because those terms are interchangeable in the Arista world and also the Cisco world. Must home to a single set of MLAG, to a single MLAG domain. And switches are monogamous for MLAG domains. Monogamous? Switches. It's like butthead. Switches. I'm going to configure some switches now. Well, troubleshooting EVPN all active can be a little trickier than MLAG. There are some advantages. There also isn't a restriction on which leafs you can connect to, or how many. All right, so this would be a good place to put this one. The example above, a single host is plugged into 3 leafs. While it's not usually a huge advantage to connect to more than 2 leafs, many DCs aren't set up to multi-home to more than a leaf pair. It does provide operational flexibility as Leafs can run on a greater variety of hardware and software combinations. They don't need to match. They could, theoretically, they could even be different vendors. Although multi-vendor fabrics are rare. I would never want to do a multi-vendor fabric. I mean, it's all open standards, but when you've got different implementations, different tool sets, different config syntax, different show commands, to try to find out the same information, it can get a little confusing, and operationally, it'll be a lot worse. There's some things you can do to mitigate that, but still, it's just a much simpler operational. There is a huge advantage to operational simplicity. So even though if you're maybe not making taking full advantage of all the options and bells and whistles and nerd knobs, by avoiding some of them, you actually may end up with a more stable situation, a more cost-effective situation, because you're not getting all fancy. Either way, in the data center, you'll generally want to run one of the... Oh yeah, it's even possible to have some switches in an MLAG domain, or it's even possible to combine methods in your fabric. Some switches lags to hosts can be configured for EVPN all active, and other switches can be configured as MLAG domain, MLAG pairs. However, operationally, this isn't generally a good idea. Pick one. This generally isn't a good idea. I've generally preferred MLAG as it's more well known, but lately I've been more into I've been preferring EVPN all active for the operational. Or is it an MLAG? There was a peer links. The lack of peer links will save to interfaces that you can then use for hosts. This is often a consideration for large fabrics where the number of ports eaten up by peer links really adds up. There also is a restriction on which leafs you can connect, to, or how many. Okay. So I think I've covered that pretty well. I've generally preferred MLAG as it's more well known, but lately I've been preferring EVPN all active for the flexibility it affords. but either method will work just fine. Even in a campus network environment, should choose one or the other just for these. In campus, well, let's see. In campus environments, multi-homing isn't as critical usually. Isn't usually as critical as it is in the DC. You should still pick a method. Know which to use. So you have that option in the campus case, campus when the need arises. All right, let's look at this. The topologies of the nodes, leaf spines, etc., and how they're plugged into each other. How many leaf spines and possibly super spines do you have? How many connections are between them, etc. Generally, the topology will be leaf and spine. Every leaf will plug into every spine. The leaves will only plug into each other if they're in an MLAG pair, and the spines will generally not connect to each other at all. In some situations, there may be a third layer called super spines, which would abrogate distinct sets of leaves and spines, with those sets being called those leaf spine sets being referred to as pods. Point of delivery. Okay, so I'm going to move this up here. And then I'm going to do the leaf spine, super spine diagram here. So this is known as a 5-stage CLO. And then this one. Nuts. So I got a spelling thing. Oh yeah, what I could do is I could just, I need to add this. There we go. Three-stage CLO. Okay, so yeah, I should probably just make a commit here. So stage all of them. Commit them, and then sync them up. All right. I think that's a good stopping point now. It's about an hour and a half. So let's go ahead and cut it out for today. I might do a little bit more, but I think reaching the end of my endurance for this. Maybe pick it up a little bit later. I'm going to go relax and finish my tea. Thank you.